Hi, my name is Rich LB, and welcome to this week's episode of Becoming Multiplanetary. This week, we're going to be talking a little about space stations and some various topics covering around it. Firstly, though, I'd like to take a moment to introduce the co-hosts I have on show with me today, starting with Kage. Would you like to introduce yourself?
Why, yes, I would. Thank you. Hey, everybody. I am Kage, one of the co hosts of Becoming Multiplanetary, and I will now pass over to another co host of our fine programs, Miko.
Hey, I'm Mikko, the host of Deep Dive Fridays, and I'm going to pass over to our special guest, Felix.
Hey, it's me, Felix. I'm here for the second time now. I'm the host of the YouTube channel What About It?
Thank you for coming back again, Felix, to host with us on our show. It's going to be a real pleasure having you here today.
It's my pleasure. Thank you for having me.
So, Felix, yes, thank you for joining us once again. And as we said earlier, today's topic is about space stations. And not only space stations, but also the travel to and from, and where we go from here. So before we get started, do you have any thoughts you want to give on where we currently stand with space station technology?
Yeah, that's an interesting question. I could probably elaborate like 20 minutes about that. We're doing baby steps, and we have been doing baby steps with space stations, in my opinion. We've had a few so far, very small ones, and then one large one, the ISS that we all know. But even that is not really large, and I'm really hoping that with future vehicles, one of them, if it works out, being Starship, we might be able to actually make them a little bit bigger. Because right now it's like 6 to 7 crew members on the ISS. Thanks to Crew Dragon, we have 7 now, which is rather small in my opinion.
But you actually mentioned something interesting there, that it's not that large. It actually is quite big. It's about the size of I think, at least an American football field, maybe if not a European football field. But as you mentioned, it does have 7 people on board, but it's currently getting pushed to its limits. Why is it at near its capacity, even though it's that big?
Oh, that's because of the escape vehicles. You always need to ensure that the crew in an emergency can get out of the station, and so it's limited in that way that you now that the Crew Dragon can right now have 4 passengers on board, and a Soyuz module can have 3. It makes 7. That's the reason why they can't have more crew.
And in theory, they could have a short-term occupants of about 14 people if there was a Soyuz and Crew Dragon changeover at the same time.
Yeah, and in the shuttle times, they had more crew on board at a few times, because the shuttle was able to have another 7, I think, and so the ISS at some point was so filled that they didn't even have sleeping booths for everybody. They just had sleeping bags and were everywhere on the station, basically. So yeah, it could harbor more people, but yeah, it's the safety aspect that keeps them from going over 7 right now.
So let's rewind a bit there, and I know a lot of people have covered it recently. I'm just literally wanting to touch on it very lightly here, and that is Crew 1. Firstly, we all saw the launch. It was great. We all saw the heartwarming part where the crew came on board the ISS, and there was hugs all around, including the cosmonauts as well. And seeing Shannon Walker up there again is actually quite fun. She looked very excited to be back as well. So let's touch a little bit on Crew 1, and then we'll move on to the ISS. Miko, you have anything to add on Crew 1?
Even now on the ISS, they don't have sleeping quarters for all crew members, since Mike Hopkins is sleeping in the Crew Dragon capsule.
But wouldn't you think maybe that might be a little bit more comfortable for him than all the other crew members that are on board the space station? Because, I mean, he's got an entire capsule all to himself. It's newer, it's roomy. Is that really a problem?
It's probably also less noisy, which is the biggest thing on the ISS. I've seen that on plenty interviews. private space is a problem on the ISS, and also the noise, the constant noise of the ventilation system and all the systems around you. There's a constant noise in the background, and I imagine on the Dragon capsule it's quiet, which would be just fine.
And he has his own personal bathroom there too.
Yeah. Yep, I'd take the Dragon.
I think I would too. Plus, I mean, it's he's already in his escape pod in case anything goes wrong. Then all he has to do is just like quickly shut the hatch, undock, and see you guys. Hope you get back home safely
through the window.
Yeah, wave bye through the window.
But one negative side about sleeping in the Dragon that Mike Hopkins said is that he wants to be really careful not to damage the vehicle so they can actually land back on Earth.
That's true.
I would be impressed if you were able to damage that vehicle somehow. Just the sheer volume of engineering and fault tolerance that SpaceX has put into that thing. Give him a sledgehammer, he probably wouldn't be able to make much of a dent.
Well, on the hull maybe, but what about the internals?
This still...
Yeah, push the wrong button.
Don't introduce sledgehammers to the Crew Dragon capsule. I think that's a bad idea.
I mean, all it took was a improperly drilled hole to cause problems with one of the Soyuz capsules, if I remember correctly. And I would wager that just given the newer engineering and the unthinkable amount of hurdles that SpaceX must have had to have gotten over to human certify the Dragon capsule, I would wager it's pretty resilient.
So, circling back to the ISS now, we know that it's officially been approved to extend its mission through December 2024, and we also know that it may have approval even to operate until the end of 2028, although that extension hasn't been officially sounded off yet at the time of this recording. So, with the, Crew 1 becoming a reality now, and the crew resupply mission being in effect now as well, we're able to cycle crew on and off there. We're going to see a lot more science being done on the ISS now. So it's basically gotten this new lease of life almost towards the end of its life. So I'm really excited to see how many, experiments we get up there and what kind of scientific progress we're going to make now going forward up until 2024. Anybody with any thoughts on that?
Well, you're right that there is a lot of potential for science, but Felix, you said something important a few minutes ago, that we're still in baby steps when it comes to space stations. I mean, the International Space Station has been in operation for 20 years now. There have been other space stations that came before that, but it's still largely in its infancy, and it's even it's even possible to say that while we have done a lot of scientific advancements, maybe have we stagnated in that because we're still stuck in low Earth orbit.
Yeah, that's what it feels like to me too. And about the extension beyond 2024, I've recently read an article. RSC Energia, the corporation that produces the space station modules for Roscosmos, their CEO, I think, the chief in operation, has had an interview with press on November 24th, I think, where he stated that the Russian side of the ISS is in really bad shape right now, and that he says that come 2024 and maybe even before that, they are facing serious technical problems, and that could be cascading effect, the same thing that they saw on the Mir station in its last operational year. It was a nightmare. They had technical problems all around, and that he said that it would be questionable to maintain the Russian part of the ISS beyond 2024. So, and the interesting part about that is not even that Russia says, maybe we can't continue this anymore. It's that right after that, they said that they are planning their own station. I don't know if Russia has enough funding for their own station, but what that signals is that they are going apart again. China is doing their own thing. Russia then might be doing their own thing, and then it would be just the US and Europe working together again. And I think the main reason why we have the ISS up there is because everybody worked together. I hope that's not going to fall apart. So just to if the ISS is going to continue, it's really hard to maintain or to repair and upgrade the station's modules, because if you have a module in the middle that you want to maybe replace because it's too old, you would have to decouple part of the station, remove the module, and put another module in. For that, you would need a space shuttle. That's the biggest problem there. And I don't see SpaceX to be ready with the Starship by 2024 so that it could replace a space station module.
Well, let's not discount Elon time.
Yeah.
There is Elon time as well. However, effectively what I'm seeing here is we need that cargo capability of the Starship in order to be able to fire up a station for the US and Europe, as you say. Mm-hmm. But one thing I do hope that comes out of this is, even if China and Russia make their own station, I'd hate if the international cooperation that we see falls by the wayside as well, because I think very much so that the cosmonauts and the astronauts that go up there, I think they still very much have, a sense of camaraderie, a sense of family, even though they're from different countries. And I think that should still be a thing going forward, regardless of who builds stations.
Yeah, I think on the ISS there are very, very little politics. Agreed. Yep.
I'm going to circle back a bit about the Russian segment modules, because I think it was last week when the Russian cosmonauts did a spacewalk to prepare for an undock of one module, and they will replace it with another one. Have you heard about that?
Yeah, I have, but that's on the outside. Is it even possible to replace a segment, a module in the inner structure? Is that even possible?
Probably very difficult.
Yeah, so what I wanted to say is that at some point we will have to have a new station. It's not possible to maintain the ISS further because it wasn't built like that. There are concepts of space stations where you can replace every module, but on the ISS, I don't think that's possible.
But is it worthwhile, long-term speaking, to replace the International Space Station as it currently stands? Or should we take that to another level? For example, should it still be in a low Earth orbit, or should we start looking beyond those horizons?
We should, but that all depends on a lot of different countries and companies, and they will all have to work together. Even if we possess the abilities of a Starship, you have to have people making the modules, you have to have people who want to maintain them, and so on and so forth. So yeah, in my opinion, we should have something like the Von Braun station by now, but yeah, it all depends on if it's feasible, if it's needed, if there are partners who are actually willing to invest lots of money.
Well, speaking about the partners, have you heard about the Axiom Space becoming a part of ISS, and in a few years after ISS has been decommissioned, they would separate as their own space station?
Heard about it. I think that's a good idea. It would give the foundation to build something new.
So if we do build something new and we take it beyond low Earth orbit, there is at least one big hurdle that would need to be overcome, and that's that, as mentioned earlier, right now the International Space Station is near its capacity and strained for being able to hold more personnel, but if anything goes wrong, the entire crew can be back on Earth in a matter of hours, and that kind of provides a psychological safety net in some degree. And if we have a space station, let's say even as close as the moon, or especially one that's as far away as Mars or Venus, or even further still, that won't be the case where a crew that's in orbit in one of those space stations would be able to return to the Earth in a matter of hours, but instead days or even months or longer. So how much will this change the psychological effect that astronauts would feel, and how can future crews overcome that, especially when we're talking about trying to maintain a nonpartisan, politics-free mentality and keeping things, keeping psychological sanity absolutely paramount?
Oh, if I may jump in here, I think it's how to phrase this. Humans do a lot of dangerous things in the name of science, and we have the ability to, in ourselves, we have the ability to ignore danger if we want to do something. Otherwise, we wouldn't have Formula One drivers or scientists who climb into an active volcano to take a sample, and so on and so forth. There are thousands of occupations that are extremely hazardous, and still people do it. So I don't think that's gonna be a big problem. I know it's going around always that people would go insane if they would have to travel for 6 months to Mars and so on, and then they would be very, very much in danger, especially on Mars. If something happens and you can't get to safety, that's it. You're on your own. But I think that's not going to keep us. What's keeping us right now is not the fact that it would be really, really dangerous. It's the fact that nobody wants to invest money into it. It's just about economics. If it's feasible, we'll do it. That's at least my opinion. The people, you will find people who will want to, and who will be able to do it.
But it's not only the financial investment, I think, but also the purpose. That there's not really a clear purpose as to what are we financially investing into. Previously, just a couple of years ago even, there was a long-standing idea of making a lunar gateway, having a space station in lunar orbit as kind of a docking station onto the next venture, and now that's effectively out of the window. So what would the next evolution in space station technology be? What would be the next purpose that would be a viable financial investment? It still begs the question of what is the ultimate purpose of building a space station. So if you look at the International Space Station, the purpose there was twofold. One, to have a perpetual place in space where science and experiments and more research and learning could be had and done. But secondly, also as a kind of a Switzerland of space, where everything was neutral, everyone worked together. There were no politics that got in the way, for the most part. But then, what would be the purpose of the next evolution of space stations? Let's say we move on to a space station circling Mars or the Moon or somewhere else. What would be our next purpose for this journey?
If you compare it to the Wild West scenario that we had in the United States when they colonized further and further, you can see that big industry always moved in after the settlers came, and then they had a foundation with which they could build their businesses. And that's the problem we're facing when we go to Mars or when we build a huge space station, because there is nothing out there yet. You cannot build a business on nothing. You have to have something that you can earn your money with to be to give an incentive for the companies to actually invest. Because I don't think that if we're talking about colonization and resource mining and all that kind of stuff, I don't think that governments are going to do that. That would need the private sector. So yeah, there are a few things that NASA is right now doing to try to build a low Earth orbit economy, as they call it, but that is hard to do, even in low Earth orbit. You need to have some sort of reason to build that shiny large space station, or you need somebody like Elon Musk who says, I don't care, I don't want to earn money with this, I earn the money somewhere else and I invest into the Mars colony. That's basically, in my opinion, the only way how you can do something like that, because then once the colony is there, it'll need supplies, resources, there will be people working as hair cutters or whatever, and the cleaning lady will come in and earn money. But that only happens once it's there.
So I feel like the international I feel like the international cooperation aspect of why the International Space Station came about, especially not so long after the end of the Cold War and the fall of the Berlin Wall and collapse of the Soviet Union, and this real necessary, this need to unify two superpowers on Earth, that's kind of fallen by the wayside. So is it possible that we could have that kind of international cooperation again without that need to create a space Switzerland to create the next international space station beyond low Earth orbit? Is there a purpose that we could collectively, as multiple nations, get behind in order to finance that and drive that purpose for the next bastion of technology and space exploration and scientific advancement?
Yeah, like I said, I don't think so. I think in the beginning it needs somebody who says, I'm just going to invest into it. This angel investor mentality is needed for that. Somebody who just steps up and says, I think that's a great idea. I'm going to pour a lot of money into it to see what comes out in the end. Because otherwise, why would you want to go out there? We have everything here. We have more here than we could get anywhere else. On the moon, you can do science, but anything, you don't want to take a walk on the moon. It's much nicer to do it in the woods here on a nice summer day, and it's much easier to do. And it's the same for Mars or for a space station that's further away and that is large, because you don't need a large space station to do science. You need a small one. And so on and so forth. So if you want to go big, you need that initial investment, and at least in my opinion. Otherwise, yeah, it's really hard.
One of the challenges with that kind of an initial investment is that if you look at how NASA has classically done things, they are very much in to use a software design terminology here, they're very much of a waterfall style where they analyze and discover all variables, control those variables. They have full control over their proximate resources. They discover what approximate resources they don't have, acquire those, and take years and years to properly research and develop things until they have absolute perfection to put into space. That's clearly not what SpaceX does. So it would take an incredible amount of not only money for an angel investor to build the next generation of a space station, but also a lot of trial and error to do so as well. How can a organization like SpaceX or somebody else do that without just ending up bankrupting themselves over potential failure after failure after failure until they get it right?
How to phrase this correctly? Okay, so you gave NASA as an example of years and years of testing and very, very much down to the detail. Every screw basically is tested and it's twisted 470 degrees to be locked in. You know, it's everything has a plan and has been developed in some way. I don't think that is necessary. A best example again is SpaceX. The reason why they are so much faster, and in the end the products are really, really good. I mean, the Falcon 9 is the best rocket out there right now, and the Crew Dragon seems to be the best capsule out there right now, even though they were faster than anybody else. So I don't think that it's necessarily bad to be faster. It just needs a different approach. And the Starship is I think the main reason why people perceive the Starship as something so different right now is because they don't see that this is not the Starship that is going to fly people to Mars. What we see in Boca Chica right now, and the dirt and the dents in the hull and all that kind of crude-looking stuff, is not what's going to fly to Mars. This is just foundation-level engineering, basically. It's just to find out how to build that Starship that will fly us to Mars. That is not going to have dents, and it's not going to be built on a dirt hill. So I think that is somewhat confusing if people look at the Starship and think, wow, how is this? I mean, how could you build a space station like this? You could, but you wouldn't build a module for the space station like this. You would just test different ways how to build a module like this. Fast, dirty, and cheap. Because in the beginning, nothing else is needed if you take the approach SpaceX is taking, and that's a different one than NASA, that's for sure.
So, Miko, you've been pretty quiet this episode. If you could design the space station of the future, what do you think it would look like? Like, what do you think we'll see going into the future of space stations beyond the ISS?
Well, I think in the near future, the Bigelow expandable module concept would be something that could be looked on, and in the future it could be an O'Neill cylinder, but that would probably be a couple of 100 years into the future. And when we think something profitable that could be in space, there's asteroid mining. So having a space station orbit an asteroid, that could be something profitable, or even on the asteroid.
That's actually quite interesting, although I'm not sure if there are any asteroids out there that would have enough mass so that we could orbit a space station around it. So probably landing one would be your best option, I believe. However, having said that, we did see the Bennu mission recently, where they've since discovered that underneath the surface of the asteroid, it's very foamy, almost like the asteroid itself has not very much substance at all.
Yeah, no, it wouldn't be very profitable to land on Bennu, but for example, the asteroid Psyche, that has, well, it's a big one and it's almost completely made out of metal.
Yeah, isn't that believed to be a former planet core? That's a really interesting story.
Yeah, that's the one. We actually had a deep dive about that.
What about you, Kage? If you could design your space station of the future, how would it look like for you?
For me, I kind of take a little bit more of a Dr. Robert Zubrin approach to this and look at a lot of the challenges that we're going to face here. And this is a huge challenge that we have right now, is that with the International Space Station, it's very protected. In low Earth orbit, the astronauts on board can be shielded by the magnetosphere. One of the first challenges that we need to overcome is how can we survive and learn to survive when it comes to not being able to escape immediately and come back to Earth, having to truly survive on your own, and even have a little bit of a signal delay that goes with it. Granted, it's only about a second or so of delay, but still, that can really help with learning how humanity can survive that much further away from Earth. And then take that to the next step of, okay, how do we survive in a space station environment in, for example, circling Mars? But that's the part where I think that now that we've slowed down, we also need to speed up. And space stations at that point might not be the ultimate goal that we should shoot for, but maybe in fact generational ships. That if we truly are going to become multiplanetary, then why don't we also become interstellar and figure out ways to take humanity beyond just the scope of our solar system, but to the next nearest stars. There's a lot of challenges that come with that, like, how would humanity cope with that sort of thing, where, for example, middle generations have no purpose but maintenance and procreation. There's a lot of things that would need to be learned anew, but the first thing I think we need to learn is, how do we survive outside of the shield of our own planet?
Well, it just so happens our radiation specialist is here. Would you like to pass off to him?
Yeah, sure. Joining us is Fremric. And yeah, Fremric, do you have anything you'd like to add to this?
Yeah, it's an interesting challenge, isn't it? So low Earth orbit has some of the protections you mentioned, the magnetic field. I mean, they obviously have to watch out even in low Earth orbit. The altitude they reach, I think there's a 500 kilometer ceiling, which NASA sets, otherwise you start to drift into the lower edges of the Van Allen belts. and radiation doses go up when you pass over something called the South Atlantic Anomaly, where the magnetic fields curve down towards the Earth and the protection is a bit weaker. It's got to be just like life support, part of the design of something as you head further out into the solar system. Bigelow modules, for example, have some proprietary shielding, Kevlar light materials to try and slow down cosmic ray particles, and then a little bit of heavier material to cut out some of the photon gamma ray energies, and so on. But in the same way, you're going to design a closed loop life support system to recycle water and air. You need your power. I think you need some shielding in there as well. There's quite a lot of information, people saying, the doses aren't too bad, but if you are out there for a long period of time, you're an asteroid miner, you're going to need to have some compensation for the amount of radiation you're exposed to. Or some mitigations. There's some work being done, very good presentation on the Mars Society 2020 conference on mitigating measures like dietary supplements, where radiation tends to cause an interaction in the body. You get what's called free radicals that can start to attack DNA and cause damage. That's what radiation damage is, really. But if you eat the right diet, you can mop up some of these free radicals. So there might be a combination of actual physical work on spaceships or habitation, but also looking at how to protect the organic life forms, the squishies within.
Yeah, those are some excellent points. And there's a TV show that I've talked about previously on this program called Away on Netflix. It gets a lot of things wrong, but it also gets a couple things right. And one of those is that the ship that they're traveling in to get to Mars has a water barrier inside the exterior hull in order to protect them from cosmic radiation. And that's one of the things that I've not really seen too much on the Bigelow spacecraft or space station component. I'm not sure what to call it at this point. But would it actually have the capability to protect people to that effect, or to that degree, where, quite frankly speaking, from what I know of it, it's not that thick of a barrier between the exterior component and the interiormost wall?
Yeah, I mean, the Bigelow modules use a sort of a Kevlar-like material with a foam flexible layer inside. It's polymer foam, and lighter materials, hydrogenous materials, are really good at slowing down these really heavy cosmic ray particles, which carry a lot of energy. They're up into the sort of 30 million electron volts range, which in the stuff I'm used to dealing with is very, very high energy. So you slow these things down with hydrogenous materials. And then if you end up with that's where you use a bit of solar energy, split it into an oxygen, and then combine them again later if you're down.
And there's even some research that came out recently about the fungi species Cladosporium sphaerospermum that has the ability to absorb and maybe even block some cosmic radiation. And I think there's even some experiments being done right now aboard the International Space Station with that fungi. Fremeric, do you know anything about this?
Yeah, I mean, the two things that living organisms can teach us, and particularly when you look at some organisms around areas such as Chernobyl with an enhanced radiation background, one is the biological effect. So has a species got a mechanism of repairing radiation damage, and so it can tolerate a higher environment? That's the kind of biological assistance, if you like. And then the other one is, does it have something in its cellular structure to provide more shielding? And as I said, if you've got more melanin in there, if you've got something that actually is better than water, density of water is obviously a gram per cubic centimeter. If you've got some materials which are slightly denser but still quite hydrogenous, they could act as excellent shielding. You'd still need a layer of it. I did see some claims that they might use the radiation resistant fungi and kind of fill an astronaut's suit with it.
So since we're on the topic of future technology, I guess at this point, so what are some additional steps that would need to be taken to make future space station technology more resilient to being in deep space and supporting dozens, if not hundreds, of lives?
I would definitely say materials research, for sure, like metamaterials. So At the moment, we're currently experimenting with nanotechnology in materials. We have like nanoparticles of gold, but effectively you can combine nanoparticles of various materials into current materials to reinforce properties and stuff like that. So materials research is something that is actively being done at a couple of Elon's companies. I know they're doing the materials research into their heat tiles, and I know they're also doing the materials research into the fibers of the Neuralink as well, for lowering rejection rates and whatnot. So I would think personally, looking to the future, materials research is where it's at.
I think living life support would be a good idea, so there would be no need to fill the tanks with water or anything like that.
What about you, Felix?
I was thinking if I should say that out loud, because I have a different opinion about this. If you work on a construction site, you can get hit by a stone and die. If you work on an oil rig, there's a good chance you can die. There's lots of jobs out there that are very dangerous, and still nobody would say we cannot do that until it's completely safe. We do it. We know it's dangerous, but we still do it. And everyday people do it. It's not even astronauts. It's just normal people who choose to do this, get more pay for higher risk. I think that same thing applies to space. NASA has a high safety policy. It is not done if it is not completely safe, or as safe as humanly possible. I think that is that's the reason why I said I don't know if I should say that out loud, because there are plenty of people out there who would disagree, and rightfully so. But I think that is a boundary, and that's keeping us from reaching out right now. It cannot be completely safe. If you're on Mars, you're not in a safe place. No matter how much you invest into, material research, in my opinion, I completely agree with Rich, is a trove of stuff that we can still research for the future, and it's going to make it safer. But if we don't start, nobody's gonna ever be there, in my opinion. So yeah, it's a difficult topic, and I completely agree that nobody should be put into a position that is not safe. But as I said before, you find people who are actually willing to do it, who are looking for these kinds of dangerous jobs, and they are willing to do it. And exploring space is dangerous, in my opinion.
There is one thing, though, there's I think three things that separate. You gave, for example, working on oil rigs versus working in space. There are, though, three things that are starkly different between those, and those are purpose, cost, and politics. That with like an oil rig, there's a commercial purpose behind it, whereas with space, there's not like a financial reason to keep doing it so much. There's also on the topic of finances, the cost, whereas for lack of a better phrase, throwing more bodies at the problem on an oil rig is a lot cheaper to do than it is to put humans in space. But then there's also the optics of the politics behind it, where with an oil rig, that's commonplace, and if somebody is injured or killed on that, it's not going to cause both sides of Congress to just get into massive rabble-rousing fights, whereas with space, you make one mistake and everyone starts screaming and losing their heads. And you're right, that's definitely something that needs to change in order to make this. Yeah, it needs to change in order to make this something that's a lot more possible to do, but more so have a lot more frequency of doing it. That mistakes will be made, some people will unfortunately die, but it needs to also have that same it needs to have at least some similar purpose, cost, and political less politics that's
exactly
that go into something no different than working on an oil rig or other dangerous lines of work.
Yeah, I actually I have quite a few friends who already said, because I have a habit of talking about space stuff to my friends. Comes with the occupation, I guess. And many of them say that, yeah, I would do that in an instant. I would go to Mars. That's absolutely awesome. When's the ship leaving? So it's not even about the people. The people want to do it. It's about the politics. The private sector has to do it. Otherwise, it's not. It'll be planting another flag, taking some samples, and going back.
So I really get where both you, Felix, and Kage are coming from. So I feel with Felix, there's this idea of we need to be doing this to be seen doing it, so that it inspires the future generation to carry on doing it effectively.
Yep.
We need that inspiration to lead us forward, and I believe that's very much what these new rocket providers are doing. Every time they launch, we're all sat there in awe watching the launches go up. And in terms of Kage and his response, I feel that everything we do in space it can be summed up in one word, and that's visible. Everything is very, very visible. There's people very aware of everything that's going on up there. And whenever something goes wrong, the entire world goes, oh crap. So it's one of those things that, we need to accept that doing dangerous things, danger is part of the job. But in terms of space exploration, that there has to be risk to see reward.
But that's a good point, actually, saying that it's very, very visible. Yeah, that's true. Exactly. If there's something bad happening on the oil rig, if it's not a massive oil spill, and even that doesn't always make it into the news, you're not going to hear it. It's a bit the same thing as with electric cars right now. When one of them does something wrong, the whole world hears about the autopilot that drove into the white truck. Everybody has heard it. But if there's a car accident somewhere, happens. And that's it. And that's the same thing, I think, too. Yeah, if there's a hole in the ISS, the whole world stares at it, and then they just use some epoxy to fix it, and that's it. But even though the whole world stares at it.
So I'm wondering idly, what would it take to reduce the political visibility that goes into this? And I find myself wondering, could it be that NASA and even SpaceX lately are a little bit to blame for that they have made space so visible? I mean, look at how commonplace it is for people to tune into a SpaceX launch and watch as cameras ride a first stage from launch to apogee to coming back through the atmosphere to landing on the drone ship. It's entertainment at this point. And is that part of the problem? Does that additional visibility make this an even more difficult challenge to having this as something where there's just risk acceptance, and we look at it little to no difference than the unfortunate tragedies that happen with other risky jobs? That is the visibility of this, the constant broadcasting of it, partially to blame here?
I think there's very much two sides to this argument that you present. The one side is, okay, they're broadcasting it a lot, that a lot of people are getting to see it, and what this is doing is it's making space an everyday thing, and I 100% agree with that. Every time they launch and they nail it, then it's becoming more and more standard to see this.
It's inspirational.
Yeah, well, it's inspirational, but at the same time, people are getting used to it now. It's becoming we're taking it for granted, there's another launch. Yeah, that's great. And we're used to seeing it now. But at the same time, when you broadcast this and expose it to the world, you also have the issue of, okay, when something goes wrong, a lot of people are going to see it. And because a lot of people are going to see it, a lot of press sites are going to see it, and they're going to run the stories. And media are great at sometimes spinning things a little bit too far, and there's going to be some scaremongering. But this is part and parcel of what happens when you're trying to make space normal. It's just part and parcel of what happens. It's just the teething phase of standardizing spacefaring travel for our civilization.
Yeah, and with SpaceX, you can't forget that they are doing new revolutionary things every year. So right now they are constantly feeding everybody with stuff to look at. First it's the landing booster, or first it's the Falcon 9 rocket, then it's the landing booster, then it's the Crew Dragon going to the ISS, then it's the Cargo Dragon, it's the Starship or Starlink. All those are really interesting things, and that's why everybody's watching. But I think once you have 3, 4, 5 Starship launches per day, that's maybe even low considering what Elon Musk plans for in the end. People are not going to watch every Starship launch. The first few will be super interesting, and then the launch number 678 is going to be watched by people like us, the enthusiasts. But everybody else is not going to pay any attention anymore, because it's an old thing. The news only reports about new things, interesting things. And right, like I said, SpaceX right now is feeding us these new and interesting things on a constant basis.
Yeah, I suppose when you think about the first person fly in the Atlantic, Charles Lindbergh, people lined up on either shore watching that plane come over. It's a special event. People watching it to see that it touches down safely. But then as soon as it's the 747s flying backwards and forwards each day, it becomes routine, doesn't it? And then maybe that's once you've got 10, 20, 30,000 people in low Earth orbit, the focus will go away from every single little risk to it becomes normal life.
Yeah, I think you don't even have to go that far. You just mentioned Lindbergh, and then the 747. I think even the second flight over the Atlantic wasn't watched anymore. Apollo 11, the whole world watches. Apollo 12, a few people. Apollo 13 was watched because it had a catastrophe on it. Apollo 14, nobody watched anymore. And that was flights to the moon. It's always the same thing. The public is interested in something new. And once it's not new anymore, people look elsewhere for the next new thing.
So if we come back to the more near future, what do you think, Felix? Will starships become space stations on orbit, since they actually have the inner volume of ISS? And also Blue Origin has some plans to use the upper stages as space stations.
Yeah, that's a very, very interesting thing. It's so weird when you imagine that the Starship, which is actually just an upper stage of a rocket, is so large that you could easily use it as a space station. The production cost will be low if you outfit it with a proper you need a lot of extra systems to keep it there permanently, or at least for a long-term use. You would need to have all sorts of extra systems. But yeah, it would be possible to maybe dock a few starships together, and then one starship has as much pressurizable room, the crewed version, as the ISS about, right? So it would definitely make sense. It would be cheap, it would be fast, and it's a strange thing still, though, to use the whole Starship just as a space station. But I guess it would be possible, and it's a very interesting prospect. Yes, definitely.
Yeah, absolutely.
It is absolutely mind-blowing to think about how the space station, the International Space Station, the size of at least an American football field, granted that's a lot of that solar panels, but still something spread out that far has the same interior volume as the things that we've been watching them unfortunately blow up from time to time, but sometimes hop. It's extraordinary, really.
Yeah, it's really strange.
Yeah, but with that, we've unfortunately hit our time. First, Felix, I want to thank you so much for joining us. It's been an absolute pleasure to have you on the show again. I am Kage, one of the hosts for Becoming Multiplanetary, and now I'll hand over to our other guests and co-hosts to also say their goodbyes to you. First up is Rich LB.
I am Rich LB, also a co-host here at Becoming Multiplanetary. Again, Felix, big thank you for coming back onto the show. It's been great having you here. It's been great hearing from you regarding the space stations this week. Be sure to tune in next week. Again, keep an eye on the Twitter channel. I'll be announcing topics there. And with that, I will pass over to our other co-host, Miko.
I've been Mikko, the host of Deep Dive Fridays. And Felix, thank you very much for joining us. It's been a pleasure.
Thank you very, very much for having me. Like I said in the beginning, this is take number 2. I'm already looking forward to take number 3. So you're not going to lose me that quickly. It's a really, really enjoyable podcast, and it's so much fun to do this with you guys. Thank you for having me.
And finally, we have Fremric.
Yeah, excellent podcast. Thanks very much for letting me join in, guys.
Yes, thank you for joining. Don't forget, if you like what you heard, check us out at totalspace.net. You can also find us on YouTube. Look for Total Space. On Twitter, Total Space Net. And finally, don't forget to like and subscribe videos from Felix. You can find him on YouTube at What About It. Thanks for joining us, and we'll see you all next time.